Hey everybody, Mr. Simons here. I am now going to do the second part of the absolute value lesson. Most of you are in class, but I know there were one or two people who are missing or might want to just watch this again to try and just relearn it, or if you missed something. So I'll try to cover this as clearly as possible. So we are talking about absolute value equations, and what we're going to do in this lesson is once you finish this, you should be able to write absolute value equations from seeing a number line. All right, points on a number line. And the other thing you should be able to do, so number two, is you should be able to make sense of word problems and write an equation for them and solve them. Most people can solve these pretty easily, but showing the work and writing it down is a weak point for them. So I'm going to show you how to do that, and I'm just going to tell you up front that if you're able to follow the first part and really understand that, the second part is a lot easier. Okay, the word problems are a lot easier if you can figure out how to write these. Okay, so let's take a look at this. I'm gonna make this go away. All right, so it says write an equation involving absolute value for the graph, and I kind of blocked some stuff out because I don't want to spoil it for you. So what they're saying is you've got 2 points on here, right? You've got this point and you've got this point. And they're saying, hey, those you've solved your absolute value equations. These are your two answers. Now we're going to work backwards, and we're only going to give you the answers. And now I want you to write the equation for it. All right. So this is picking up right where you left off with the last lesson. So what you're going to do, all right, is think about this for a second and say, well, what when you're figuring out what the absolute value is, it's the distance away from it's usually we say it's the distance away from zero, right? But in these cases with these problems, it's kind of like that sort of shifting. So it's the distance away from a point, or we can think of it as a midpoint. It's the distance away from a midpoint or a target point, but I'm gonna probably use the term midpoint the most. So that means that 11 and 19 are equidistant, or the same distance away from a point that is in between those that we'll call a midpoint. So we just got to figure out where that is, right? And it's really not that difficult, because if you think about it, you go, okay, 11, 19, how far away are those from each other? Well, you can just do a quick, easy subtraction problem, 19 minus 11. So that means there's 8 units of separation between those. So my midpoint has to be halfway between that. So to figure out half of that, I would just go 8 divided by 2. And my midpoint is going to be 4 units away. 4 units away from either endpoint. So it's 4 units away from 19, or it's 4 units away from 11. So it's either 4 units less than 19, or it's 4 units more than 11. All right, because it's between the endpoints. Those are the two criteria. It's got to be 4 units away, and it has to be between the two endpoints. So that means that if it's 4 units away from 19, it's between them, I would just go back 4 units. So I'd go 18, 17, 16, 15, and there you go. That's 4 units. And that also works for my 11. I would go 4 units to the right, and it would put you at the same spot. So now I've figured out my midpoint. All right, and that's really useful. I've also figured out the distance away from my midpoint, which is kind of like my temporary zero, if you think about it that way, all right? My midpoint. So what I'm got now, I've got enough information to write this equation. Okay, so I'm going to say, okay, I know that it's going to be x minus something, because that's just how most of them work, equals something. So I got to just think about what goes where. Well, if you know what an absolute value is, the distance away something is from zero, or like we said, from our midpoint. So if it's the distance away it is from the midpoint, and that's the absolute value, and that's the left side of this equation, that means I got to put my midpoint in here. All right, so my midpoint is 15. So I would go x minus 15. And then the answer on your right is the actual number of what that distance away is. And I know that is 4, because we figured that out. So it's kind of like the formula to figure it out, and then what the answer is. So you have x minus 15 equals 4. And so the last thing you do is you just check it. and you check it by putting in the two midpoints. So we'll start by putting 19 in. So I'll do this in another color. We'll go 19 minus 15. And if that winds up equaling 4, then that one's good. So 19 minus 15 is 4, and the absolute value of positive 4 is 4. So that one worked out good. Now let's do the negative case. All right, the negative case would be taking 11. Right, so we go 11 minus 15. Well, 11 minus 15 is negative 4, and the absolute value of negative 4 is positive 4. So they both work out. They both get you to this number here, and that's what we want. So that is basically, in a nutshell, how you do these types of problems. All right, so I'm going to do 2 more with you. Okay, and then we'll do a couple word problems. All right, write an equation involving absolute value for the graph. So let's take a look at this. These are my points here. All right, so 17, 27 are my endpoints. Let's figure out where the middle is, what my midpoint is. Well, if you look at that, it's 10 units away from each other. They're 10 units away because it's 27 minus 10. Okay, or 27 minus 17, sorry. It's 10 units. So half of that would just be 10 divided by 5. Or sorry, I'm making all kinds of mistakes now. Half of that would be 10 divided by 2, which is 5. So my midpoint's going to be 5 units either to the right of 17 or 5 units to the left of 27, because it has to be between those. My midpoint's going to be right there. That gives you your 5 units right here, and that gives you your 5 units right here. All right, now I know my midpoint and I know my distance. So we're in a situation where we can start writing this, okay? So it's going to be x minus something equals something. Remember this, let's start with the right. The right side, I always know is going to be your distance away from your endpoint to your midpoint, right? Well, I know it's 5 units. So 5, that's always positive. And then this is your midpoint, goes right here in this middle spot right here. Okay, so my midpoint, which we figured out, was 22. So now let's just plug in and see if it works. All right, so let's do the left one first. So let's do 17 minus 22. See if the absolute value of that, how that works out. Well, 17 minus 22 is negative 5. And then the absolute value of negative 5 is 5. So that one worked out. And then let's try your other point. So let's try 27. So 27 minus 22 gives you 5. And the absolute value of 5 is 5 as well. So there you go. All right, let's look at one more, which kind of presents a different sort of challenge. All right, so we're going to say that we've got points at negative 6 and 2. All right. Now, what's different about this one is that we're venturing into the negative area, all right? And so it's the same concepts, nothing really changes. The only thing that's really different is that now we're looking at how do we deal with these integers, these negative sign numbers. All right, so this is my distance between these two. All right, it goes from negative 6 to 2. So 2 different ways you can figure out the distance. One, you can do a subtraction problem, which is a lot faster and more straightforward. So usually you take your right number and subtract your left number. So we're going to do 2 minus a minus 6. It's not 2 minus 6. It's 2 minus a minus 6 because this is a negative number. All right? And that will tell us our difference between them. Remember, difference is a subtraction problem. So 2 minus a minus 6 is the same as 2 plus 6, which gives us 8. So I know now that these are 8 units apart. Okay, these are 8 units apart. Now, that means that in order to figure out my midpoint, I got to divide this in half, and then I wind up, I don't know why I had that written down. I don't know. Maybe I just missed it before. So if I divide that in half, you do get 4. Okay, so that means that if I go 4 units to the left of this one, or 4 units to the right of this one, I'll find my middle. So if I go 4 units to the right of negative 6, I just go 1, 2, 3, 4. That means that once I stop glitching out and doing all kinds of weird things here, That means that this point right here is my midpoint. It is 4 units away from both of my endpoints. All right, so now I've got all my information. I know my distance, all right? So you've got x minus, and my distance away is 4 because we figured that out. And then this number right here is your midpoint. Well, my midpoint's -2. So I'm going to put -2 in like that. Now, the one thing you do need to do is these do need to be simplified equations. So I have x minus a -2. So let's fix that. Let's make that into x plus 2 because this is a double negative and becomes a plus, equals 4. And then just check your answers. All right. So let's put our negative case in, the -6. So -6 plus 2. Well, -6 plus 2 is -4. And the absolute value of -4 is 4. That one looks good. And then put in 2 plus 2 because this is 2. And then you're adding it to this 2. That gives you 4 as well. And you're golden. All right, let's do a couple word problems. Like I said, these should go pretty easy now that you kind of understand this. So a thermometer is guaranteed to give a temperature no more than 1.2 degrees Fahrenheit from the actual temperature. If the thermometer reads 28 degrees, write and solve an equation to find the maximum and minimum temperatures it could be. So your maximum and your minimum temperatures are basically going to be your distance away from where you want your temperature, right? So where we want the temperature is we want the temperature to be 28 degrees. So that's kind of like our target number or our midpoint. Our midpoint is going to be 28 degrees because it's halfway between our maximum and our minimum temperature, right? And I know that you guys can do these problems in your head, and that's great, but we have to be able to write these equations. So let's think about this now. All right, so if we did this with a number line and we put 28 right here, and then we'll go up by like a half. So this would be 29, and this one can be 29.5. Then we'll go down by halves here, right? So this is 27, this is 26.5 right here. All right, so if we do that, that means my points, right? My midpoint is 28 degrees. So that's this guy right here. And then I'm going up 1.2 and I'm going down 1.2. So that means I got something that's about like right here. And then I have something that's about like right here or so. Okay, so you've got this distance right here. And then you've got this distance right here. And those are each 1.2. All right, so we know our distance away is 1.2. So we figured that out. And we're going to have x minus something. And well, that minus is just, you just put your midpoint in there, your target number. Target number is 28 degrees. That's what they told you right there. So x minus 28 degrees. And so now you've got a finished equation. There's no weird double negatives or anything. So let's put in our numbers and see if it works. All right, well, I'm saying that if I do this, so figure this out just in your head. Well, if it's 1.2 degrees more than 28, I add that up, that should be 29.2, right? So if I put 29.2 in this equation, let's see if I wrote it right. That gives you 1.2, and the absolute value of 1.2 is 1.2, so that worked out. Well, my left end point, if you think about this, it says it's 1.2 degrees away, so it's less. If it's minimum, that means it's less. So you would just subtract 28. You go 28 minus 1.2. That would give you 26.8, right? So you just put that in, 26.8 minus 28. And basically, we already figured this out, but we're just checking it, right? Negative 1.2, so that becomes positive because it's absolute value. So hopefully, at this point, you're realizing, hey, these really aren't that hard to write, okay? But we'll do one more just in case. Okay, let's look at this last one. And, and if you want to pause the video and try it, you can. Probably not a bad idea. All right, so ice cream should be stored at 5 degrees Fahrenheit. So that's kind of important. That's your ideal temperature. with an allowance for 5. So that means, all right, if they're telling you it's an allowance, that means that it could go up 5 degrees or it could go down 5 degrees from your target point. And your target point's 5 degrees. So now we know our range. Be able to figure out on your own what your upper point is and what your lower point is, okay? Without even needing to do this, you should be able to say, oh, well, it's going to be 10 degrees and 0 degrees. That's easy, right? So now what we're going to do is we are going to write our equation. So I know that my target point goes in here, right? My target point always goes in there. And then this number off to the right of the equal sign is always my distance away. Well, the distance away is 5 degrees because it can't be more or less than, it can't be any more than 5 degrees away from it. So let's check this now and see if our answers worked out, the ones we just figured out in our head. Well, we said 10, right? If you put 10 in, you got 10 minus 5 gives you 5, and the absolute value of 5 is 5. So that worked good. And we said 0 should work, right? So 0 minus 5 equals 5. Well, 0 minus 5 is negative 5. And then the absolute value of a negative becomes positive, so you have 5 equals 5. So that one worked out too. So it's a pretty easy way to check your answers with these and get them started and all of that. So hopefully this helps you a little bit. And if you have any questions, you know how to reach me. So thanks for following along, and good luck with these problems.